Minley's house is located 1.4 miles from her school. When she walks home from school, it takes her an average of 24 minutes. Assuming that Minley walks at a constant rate, and we could figure that out because we know how far she walks in a certain amount of time, which of the following functions best models Minley's distance from home, d, in miles, so we want distance in miles, if she has walked a total of t minutes. So t is going to be in minutes, so all our units are going to be minutes and miles, and that's good because they gave us things in terms of minutes and miles. If this was in seconds or hours, we would have to do some conversion. So let's just think about her rate, her constant rate that they're talking about. The rate that Minley walks, well, she covers 1.4 miles. She covers 1.4 miles in 24 minutes. 24 minutes. Well, this isn't a pretty fraction with the decimal in the numerator, so let's multiply the numerator and the denominator by 10 so that we get rid of this decimal. So that's going to be equal to 14 over 240 miles per minute. And then we can further simplify that. The numerator and the denominator are both divisible by 2. So this is going to be, let's see, 14 divided by 2 is 7. 240 divided by 2 over 120 miles per minute. Miles per minute. So we were able to figure out Minley's constant rate. Now we need to figure out d. We need to figure out d. We have to be very careful. d is Minley's distance from home. From home. She's leaving from school, and it's her distance from home. Remember, her home is 1.4 miles from her school. So there's a bunch of ways that we can tackle it, but maybe the easiest one is, well, what's her distance, if you wanted to say distance from school, distance from school, that's just going to be her rate times t. Times how much time has passed by. As when time is 0, she's going to be at her school. As time increases in minutes, she's going to get further and further away from her school. But her distance from home is going to be 1.4 miles minus the distance from school. So let me just write d, because this is what we care about. d, which is her distance in miles from home. Distance in miles from home. That's going to be 1.4 minus distance from school. Minus distance from school. And if that doesn't make sense, just think about it. If this is her home right over here, I'll write H for home. If this is her school right here, S for school, we know that this distance right over here is 1.4 miles. Now, if she has walked, say, let me do this in another color. If she has walked, 0.4 miles, if this is 0.4 miles right over here, then her distance from home is going to be 1.4 miles minus that. It's going to be this distance right over here. So distance from home is going to be 1.4 minus the distance from school. And what's that going to be? Well, that's just going to be 1.4 minus the rate times the time. Well, what's the rate? 7/120th miles per minute. We got the units right. And so this is d is going to be equal to 1.4 minus 7/120th t. And if we look at the choices, that's going to be this first choice over here. And it's fun to look at the other choices and to think about, well, how could we have ruled them out fairly quickly? Well, this one has 1.4, the distance between the two places, minus 24t. Well, this isn't the rate right over here. That's how long it takes her to walk. It's not the rate, so you could rule that one out. This one is 1.4 minus the reciprocal of the rate, so that's a strange answer. And this one makes it look like she's getting further and further from home as time gets bigger. Notice this one right over here, it does correctly say at time 0, she's going to be 1.4 miles from her home, which is accurate because at time 0, she's going to be at her school. But then after 1 minute, after 2 minutes, after 3 minutes, she's going to get, based on this model, further and further away from her home. So this would be a case where she's walking away from home from her school. So you would rule that one out as well.